So my name is Prem Ramaswami. I'm a product manager with Google.org, which is Google's technology-driven philanthropy. And I'm here today with my colleague, Steve Hakusa, who's a software engineer. And Steve and I together work on Google.org's crisis response team, which looks to make crucial information available in the aftermath of a natural disaster. Now, we're here today to talk about how developers like yourselves can feel empowered in the aftermath of a crisis. We're always interested in your feedback, which we'd love for you to share either on the goo.gl links or any of the Twitter hashtags behind me. With that, I'd like to get started with our story. As a team, our story starts on January 12th of last year. Now, on this day, you might remember, there was a 7.0 magnitude earthquake that hit the island nation of Haiti outside of their capital city of Port-au-Prince. Now, this earthquake ended up killing over 250,000 people. It left another million homeless and 2 million in need of food and water aid. As images started escaping from Haiti, a group of us Googlers got together and wanted to see what we could do to possibly help out. Now, Google has been responding to crises since about Hurricane Katrina, and the way we do that is by collecting updated satellite imagery and publishing it to our properties like Google Maps and Google Earth. Aid agencies then use that imagery. So in the aftermath of the Haiti earthquake, we were actually able to collect a cloud-free shot over Haiti with our partner GeoEye, and we were able to publish this imagery to Google Maps and Google Earth within the first 24 hours. Now, this imagery really gave us an understanding of the level of devastation and destruction that had occurred over the country. Now, I said that aid organizations make use of this imagery. It's not just there for the shock value of it, so I want to give some key examples of how aid organizations take advantage of this. The World Bank, for example, used this to conduct wide area damage assessments. Other organizations used it to identify the location of refugee camps. It was also a nice way to visualize the location of all your clinics on a map that were popping up in the aftermath of this disaster. Now, you can imagine why having this information geographically placed is so important. For example, you want to make sure these clinics are set up next to your refugee camps, so you're properly servicing the right populations. And I want to give another specific example of where satellite imagery is super helpful. This is the Pétionville Golf Course, which is located about an hour south of the city of Port-au-Prince. And this is a satellite image of the golf course about 6 months before the earthquake. A day after the earthquake, you see little white specks popping up on the golf course. And these are actually tents. Individuals who live in the surrounding areas whose houses are either destroyed or they feel unsafe with a concrete roof over their head have now moved onto this golf course. And 13 days later, the entire golf course has become a refugee camp, one of the largest in Haiti. Now, camps like this are easily identifiable by viewing time-lapse satellite imagery. Not just that, by knowing where these refugee camps are, aid organizations can make sure they're appropriately allocating their resources. But as I said, we've been using the satellite imagery since about Hurricane Katrina. So when this group of Googlers got together, we asked ourselves, what else could we do here? Now, Google's mission as a company is to organize the world's information and make it universally accessible and useful. And so we decided we'd organize all of the information related to this disaster in one place on a web page, and we called this a landing page. And so we started organizing this information, which included things such as where to donate, along with actual ways that individuals could help, news and updates that were coming out of the region, relevant maps, as well as user-generated content such as YouTube videos. This page was launched in 12 different languages, and it was linked to from the google.com main page, as well as from what we call enhanced search results. So if you looked for something related to Haiti earthquake from google.com, you'd be linked to this page. I wanted to spend the next few minutes going through some of the specific features that were on this page. And one of those products that we actually launched was a tool called Person Finder. See, after the Haiti earthquake, there were more than 14 separate sites that popped up to take care of missing persons information online. Now, all of these sites were referring to missing people with different standards. They were using different infrastructure, and none of them were integrated, which meant that if I were missing a relative, after the earthquake, I would have to go to each one of the 14 sites, search for them, enter their information, and keep continuously looking at all 14 to try to find updates about them. Now, this was a place where Googlers felt we could really help out. See, we wanted to build a simple web application that was super easy to use. We wanted to use an open standard, specifically the PFIF standard, or the Person Finder Interchange format. And we wanted to make the tool open. So we'd give open access via an API so all of these different sites could push and pull their data to and from it. And so we had this 72-hour hackathon that occurred globally in Mountain View, New York, Zurich, and Israel. And engineers around the globe worked and launched the Person Finder web application on App Engine. And we noticed something interesting happened. Sites like CNN, NPR, the New York Times integrated to Person Finder. And as a victim, I no longer needed to go to all 14 separate sites. I could go to any one of them and now see that same information mirrored across. Now, another area where we thought we could help out was with relevant mapping information. See, there was a lot of maps that were being created in the aftermath of the earthquake, and this included stuff like the World Bank's damage assessment I showed earlier, or even things as simple as earthquake locations from the USGS. Now, the problem was this information was strewn across the web, and it was in different formats, often not machine-readable formats. And so our engineers crawled the web, found a lot of this information, scraped it, converted it to a common format like KML, and then placed it on this common map that we then linked to from our landing page. Now, you could just click on and off any of the layers here, and as an aid organization or someone interested in understanding what's happening on the ground, you could get more of a complete picture, because you could layer on different layers from different organizations. And it wasn't just Google that was helping out in this tech space. There were organizations like OpenStreetMap. So OpenStreetMap is a collaborative mapping platform, very similar to Google's own MapMaker. Now, what OpenStreetMap did was they took advantage of the local Haitian diaspora that was around the world with relevant knowledge about Haiti's roads to actually digitally draw them out on a map. Now, why is this actually useful? As an aid organization, when I come to Haiti and I want to deliver my aid from point A to point B, I need to know how to get there. And the fact is there were no good maps to help people out. The work done by the Haitian diaspora community in OpenStreetMap ended up being quoted as the most complete digital maps of Haiti's roads ever created. And it was hugely important. Ushahidi also emerged as a very important platform after the earthquake. Ushahidi was initially created to report post-election violence in Kenya, but it's a simple incident reporting platform. Now, what that means is individuals come to it and they say something has happened. That gets categorized by a group of volunteers and then placed on this map. Now, why this is helpful is you can start seeing clusters of information start appearing in a map like this. For example, as an aid organization, I can come to a site like Ushahidi and start seeing areas that are in need of immediate food aid. Or I can see areas which have outbreaks of violence occurring, so I can keep my staff away from them. Now, it's important to note that Ushahidi required you to be able to submit these reports via web, and not every Haitian had access to a computer, especially after the earthquake. But everyone did have mobile phones. So a large coalition of nonprofits, including Ushahidi, Frontline SMS, and Instead, worked to launch the 4636 project. Now, 4636 was a free SMS shortcode. Individuals on the ground could SMS a message to the shortcode that got picked up by a group of volunteers on the back end that would then again categorize it and place it on a map. Now, this not only made maps like Ushahidi richer, it actually helped save lives. There's an example from Haiti where individuals stuck in rubble would SMS their messages on their location that would then get picked up by these volunteers who would place it on a map and relay that message to the US Coast Guard or US Southern Command. Using this method, over 100 lives were saved. Now, this isn't to understate the importance of technologies like radio and TV, but the fact is the internet was having a key role in Haiti, and we had some metrics to prove this. So Google's landing page had over 4 million page views. There were over 80,000 text messages that were handled by Project 4636. There were 2,500 volunteers around the world managing those messages, and there were over 100 lives saved. There were over 55,000 missing persons records stored in Person Finder by the end of the Haiti earthquake. And in addition, The American Red Cross collected $32 million with an SMS text campaign in the US. This is the largest amount ever collected by one organization for a single campaign. Finally, thousands of contributions were made to both OpenStreetMap and Google MapMaker. And as we said, OpenStreetMap ended up being the most complete map of Haiti's roads ever. And so a group of us decided to travel to Haiti to actually understand the situation on the ground and see where else technology could have a key role. And I wanted to give two small examples from our trip down there. This is a doctor writing patient care instructions on the floor outside of a patient's room. And this is a map of a field hospital's resources. Now, these were areas where we believed that technology really could help out. So upon returning back to Google, we actually spoke to Larry and Sergey, Google's founders, and we pitched this idea of a team, a Google.org crisis response team. And it would be modeled very similar to other Google.com project teams with core engineering and product support. And our mission as a team would be to make this crucial information more accessible during natural disasters and humanitarian crises. Now, Larry and Sergey were not only supportive, they were extremely enthusiastic at the possibilities that technology could have in this space. Now, we knew that we'd never be domain experts here. But what we did know is that we understood web technologies, and we wanted to bring that understanding to assist aid organizations and victims after a disaster. So before I go into any more detail, I wanted to invite my colleague Steve up to stage to talk about how our team has evolved over the last year and a half and how the crisis response ecosystem has developed. Steve?
Thanks, Prem. So Prem just showed you a number of internet-based tools that had a measurable impact on the response in Haiti. And we think this is just the beginning. At Google, we're excited that a number of organizations see the Haiti earthquake as the start of Crisis Response 2.0, as a turning point in using widely accepted consumer technology to mitigate crises. Google's looking to do much more in this space, working closely with a number of other organizations that are doing similar great things. But this isn't enough. We also need your help. These crises aren't going away. We've responded at Google to more in the first quarter of this year than all of last year combined. Now's the time to jump in and get started. I want to give you an idea of some of the problems and challenges that we see in this area, both for us and for developers like yourselves, and then show you how we're using openly available Google technology and web standards to be able to help. The first question you might have, though, is, does the internet even work after a disaster? And it might be surprising, but in every single crisis, major crisis that we've seen since Haiti, the internet has stayed up. And how do we know this? In three different ways. The first is local ISPs, which continue to broadcast routes from their edge routers. We pick these up, and after a disaster, we still see them happen. The second is traffic to Google sites from the affected areas. And the third is the stories that we hear of people on the ground using the internet as a critical tool for communication in the immediate aftermath of a disaster. The internet was designed to be resilient, right? To take advantage of robustness and route packets along the path of least resistance. And we see people taking advantage of that. Haiti was a worst-case scenario. It's an impoverished island with poor infrastructure and low internet penetration. The earthquake actually severed the only fiber cable coming into the country, leaving just a microwave radio link to the Dominican Republic. And with the scope of the disaster, we couldn't hope for much. But fortunately, internet and telecom companies were better prepared, and they survived pretty much intact. This is a graph of traffic to Google from Haiti on January 12th, 2010. You can see that when the earthquake hit, there was a large power outage, and traffic to Google dropped. But you'll notice, importantly, it didn't drop to zero. The internet stayed up. We heard numerous stories of people on the ground using smartphones, getting on Facebook and Twitter, telling friends and family that they were OK, and providing some of the first on-the-ground news reports of the level of destruction there. Because of the situation in Haiti, it took 4 months for the internet traffic to Google to return to pre-earthquake levels. But the internet was always up. Just a couple weeks after the disaster, we heard people in the Petionville golf course camp that Prem showed you pictures of before, watching YouTube videos. The internet was there. This is a similar graph in Chile, February 27th, 2010. This graph, the axis is a little different. Each peak and valley represents a single day. Traffic rises during the day and then drops at night. The red line represents an 8.8 magnitude earthquake that struck there in the middle of the night. There's a resulting tsunami that hit a major network hub in Santiago. And we actually did stop seeing from the ISPs routes being broadcast, but only for 15 minutes. After that, the internet was back up, and you see within a week, traffic had returned to pre-earthquake levels. Here's the situation from New Zealand after the Christchurch earthquake just this past February. You can see when the earthquake hits, there was barely an effect on internet traffic. We had conducted numerous interviews with people on the ground in Christchurch. And they said that phones, after the earthquake, phones were saturated. They would not work. SMS wouldn't be delivered at all or would be delivered hours late. But the internet was fine. People said email was the only way to communicate after the disaster in Christchurch. Vince Cerf, one of the founders of the internet, says, "The internet was designed with a significant degree of resilience built in, and I'm pleased to know that it has often served as an important platform for communication during emergencies." Now, Vin also wanted me to point out that this resilience shouldn't be confused with the ability to resist determined attacks, right? But I think the point here is clear, that the immense value that the internet brings in communication and data sharing also applies to disaster situations. So given that, the next question to ask is, what problems are there? We look at that and say, who are our users and what are their needs? We see 3 main groups of users. First are those directly affected by the crisis. Then there are friends, families, neighbors, those indirectly affected. And finally, the crisis responders and aid workers who arrive to help. We're looking at the needs of each of these groups, and particularly where they overlap. For those directly affected by the crisis, the most important thing is the status of their friends and family. Getting access to information in a crisis is challenging, specifically trustworthy information. They also want to know, how do they tell other people that they're okay? Where can they go for help, and what's the status of resources, like medical facilities, power, roads, public transportation, shelters? And finally, those directly affected by the crisis are often the first line of crisis responders. They want to be able to help, but I think technology can do a better job of telling them where they should be to help. For those indirectly affected by the crisis, again, the most important thing is, what is the status of my friends and family that are affected? They also want more detailed information from the ground, reports from victims, what is happening. And these people also want to be able to help. They often have unique knowledge of the language, the culture, the geography of the area. We saw that OpenStreetMap example, tapping into the Haitian diaspora to improve the base maps in Haiti. And we think there's a lot of other ways to leverage this highly motivated group of individuals using technology. And the needs of crisis responders is actually where developer tools might help the most. Most crisis responders don't have technology backgrounds, right? But at the same time, they have to be able to collect and analyze a lot of data to figure out how best to distribute aid. They need better tools to visualize survey data, to determine what other responders in the area are doing, and how they can share data with them, figure out where their own staff and supplies are, and make sense of the torrent of crowdsourced and social media data that's coming in. I think there are better tools that we can design to help these. You might already be thinking, what are some from your background? What are some of the things that you could do? How could you build some tools to help these people and help meet these needs? I want to walk you through some of the standards and some of the tools that our team is working on. You'll notice 3 common themes in the standards that I'm talking about. First, simple. Crises, obviously, are stressful situations. People aren't thinking straight. As much as possible, the tools that you work on and that get used in a crisis have to be simple. And even better if they're familiar, if they use things that people already use in their everyday lives. Second is standard. As much as possible, we want to use and promote common standards to enable different organizations to interoperate. And finally, open. Open data licenses, open APIs, open source code. Open systems really win in this space. Person Finder is a great example of these three themes. It also meets one of the key needs that we saw from multiple user groups, finding the status of friends and family. Now, Person Finder is an App Engine application, but more important is the data standard that underlies it, the Person Finder Interchange format, or PFIF. PFIF was created after Hurricane Katrina by Ka-Ping Yi, one of Google.org's first engineers. And again, as Prem mentioned, the major design principle behind PFIF was convergence, bringing data together from multiple different sources and systems. For something like this to work, data has to be traceable back to its original source because data might have unknown reliability or accountability. PFIF also assumes that there's no central authority. So if you're an aggregator of this data, you can decide which data sources to trust. But in a system like this, duplicates are inevitable. You're going to have missing person records for the same person. So the format has to be able to handle that and resolve duplicates. The data model for Person Finder is very simple. There's just two types of records. First is a person record. This is entered by someone who's looking for a missing person, or you can actually enter a person record for yourself if you want other people to know that you're OK. Then there's a note record. And this is entered by anyone else that has a status update about that person. There can be multiple note records for every person record. And note records are also used to resolve duplicates between different persons. Person Finder has a data API. It's built on XML, REST, and Atom. Simple, powerful standards I'm sure many of you are familiar with, and is used in many Google tools. The Search API allows you to enter all or part of a person's name and get back the person and note records for that person. There's a Read API, where you can enter the identifier for a person, or get an Atom feed of all the person records or all the note records. And then there's a Write API. You construct person records and note records as XML, and HTTPS post them along with an authorization token. Any of you can try out this API right now by going to our test instance at googlepersonfinder.appspot.com. The user interface to Person Finder is fast and simple. If you're searching for someone, just say, I'm searching for someone. You enter their name. You'll get all the records that match this person's name. Find the correct record, and on the left-hand side, you'll see the person record. And on the right-hand side, you'll see all the note records for that person. You can also enter a new record, a new note, if you have a status update for that person. Person Finder is an open source project. It's hosted at encode.google.com at Google Person Finder. If you'd like to help, you can go to the site, check out the code, you can play with the API, or maybe pick up an issue from our issues list. There's also a mailing list that's available if you have any questions. The next set of user needs that we're looking at is the status of resources. And in Haiti, we saw a number of different organizations trying to collect this information. The US Army was surveying the status of roads. The World Health Organization was trying to figure out which hospitals were open. And the Red Cross was tracking the status of what shelters were being built and where. This information was useful to crisis responders. And we found that they were sharing it by passing email and emailing each other spreadsheets. This meant that crisis responders spent a lot of time merging rows together, copy and pasting between spreadsheets, doing a lot of things that a database could do. Not only is this inefficient, but it doesn't keep up with the rapid pace of change in a crisis situation. So what if we could automate this? Both the merging of data in spreadsheets and also the exchange of data between organizations. We could make it a lot faster and simpler for people to understand the current status of resources in a disaster. We envisioned a project called Resource Finder. The goal is to enable structured updates to information about resources in near real time from multiple sources. So what's the simplest possible way to do this? We start with multiple sources, each with information about one specific type of resource. If anyone wants to add something, remove something, or change something, they would publish that change. The change could then be broadcast to anyone who's interested in receiving it. Now, for this to work, everyone needs to have the same identifier for a resource. We'll call that a record. And users will also want to know which source made the change, right? So you also have to tag each change with an author. Finally, these changes may come out of order, so they also need a timestamp. So for this change, you just know what changed, who changed it, and when did it change. Imagine a stream of these changes. If you have that, you should be able to just merge them together to create the current status of all the resources. We take a specific example of hospital facilities. Say the Army, again, from a survey they did in March, knows the status of the road access. The Red Cross knows which hospitals are open and how many beds are available from a survey they did last month. Let's say maybe a specific doctor knows there was a road washed out yesterday, and now there are more patients available. And using the authored information and the timestamp information, you can merge all the columns together and merge all the rows together to get the current status of all the resources. Now imagine multiple applications publishing and subscribing to this information using an open protocol like PubSubHubbub, which was announced at Google I/O last year. Some of these subscribing applications could send email or SMS when a hospital is out of beds. Or maybe it's just an online spreadsheet that your organization wants to keep up to date. Or maybe it's an instance of Ushahidi that I want to keep up to date. We built a project called Resource Finder on App Engine. And we focused initially on hospital facilities in Haiti. It turns out this actually wasn't that well adopted. Organizations liked receiving this information in near real time, but they didn't want to have to learn a new tool. So we're rethinking our work here. We're trying to extract the core ideas from Resource Finder into a protocol that we can integrate into tools that are already being used on the ground. We're calling this Tablecast. The name comes from the fact that most data is in tables, and we want to be able to broadcast it. It's an Atom extension that represents a stream of changes to a data set. And since it's Atom, it also integrates very well with a PubSub protocol like PubSubHubbub. Just like before, it represents what changed to what record, who changed it, and when did it change. We're still actively developing this specification, but we're looking to build libraries and tools to integrate this into what's already being used on the ground. If you're interested in the specification or want to participate in the working group, you can check out tablecast.org. The next group of user needs we're looking at is their access to public alerts and warnings. The problem we see here is that many organizations that produce these alerts use their own format and their own distribution mechanism. Some have publish alerts to their website. Some have a Twitter feed or an RSS feed. Some offer email subscriptions. Some don't have information like this online at all. It'd obviously be much better if all this information was online in a standard format. It turns out there is such a format. It's called the Common Alerting Protocol. It's an XML specification that normalizes formats across many different types of alert messages. And it offers flexible targeting of things like language, category, and geographic area. CAP was developed in conjunction with over 100 emergency managers, and it's been adopted as an international standard by OASIS and the ITU. Organizations like the National Weather Service and the US Geographic Survey already produce alerts, feeds of alerts, in the CAP format. We're working with many other organizations to standardize their alerts as CAP. And we've open sourced a Java library and some tools to help get alerts into the CAP format. We're also trying to standardize how alerts are distributed across the web. We're encouraging providers of alerts to produce Atom feeds in the CAP format, and we're going to aggregate them at a common instance of PubSubHubbub that we're calling Alert Hub. Final standard I want to mention is KML. I'm sure many of you are familiar with it. Our goal here is to get information related to a disaster on the web in open formats before the next disaster strikes. One tool that we've found to be particularly helpful with this is Google's Fusion tables. There's a session in this room at 1:15 about fusion tables that I would encourage you all to attend. Fusion tables has some awesome features. There's two things that we like about it the most. The first is that it's really simple. If you have a spreadsheet and it has a column for latitude and a column for longitude, or it just has one column for addresses, you just upload that spreadsheet to Fusion Tables, and you immediately have a map that you can share across the web. The next thing with Fusion Tables we like is that it scales. It scales to tens of thousands, hundreds of thousands of rows in your data. And it also scales in terms of queries per second for people accessing your data. We see this kind of traffic on our landing pages. And we've had situations where we haven't been able to link to data on somebody else's website, even if it was really good, because we were afraid of bringing that site down. If the data's on Fusion Tables, we don't have to worry about that. Fusion Tables also works really well with the Google Maps API. This code's actually from one of the pages that we launched responding to a crisis. You can see it's actually really easy. In Fusion Tables, the URL has an ID for a Fusion Table. And inside the Maps API, there's something called a Fusion Tables layer. It's a first-class citizen there. You just plug in the ID to create a Fusion Tables layer, set the map to that layer, and you automatically can render thousands of points server-side, just like Google Maps does. This also works really well for polygon data, so you can display heat maps and things like that. Fusion Tables is really powerful and really well integrated into our tools. So to sum up some of the standards that we've been talking about, Person Finder interchange format for missing persons data, Tablecast for enabling real-time updates to tabular data, the Common Alerting Protocol for public alerts and warnings, and KML for geographic data. We want to keep things simple. We want to promote these standards. And we want to promote openness. Open APIs, open data, open source code. Open systems win.
Thanks, Steve. So Steve just gave us a deep dive into a lot of the tools we've been working on over the last year and a half. And what I wanted to talk about was how these were all very useful during a recent crisis response. On March 11th of this last year, there was an 8.9 magnitude earthquake that struck northern Japan in their Sendai province. Now, this earthquake was so large that the Earth literally moved 4 inches on its axis, and the island of Japan moved 6 feet closer to California. We immediately sprung into action and wanted to collect imagery over the affected region. The video you're seeing playing, the top part is imagery from 2009. The imagery at the bottom is aerial imagery we collected with the fleet of planes. Now, this imagery had enough resolution to see individual cars, but more importantly, it showed us the level of damage and destruction that had been created. Entire cities were completely wiped off the map. Now, seeing this level of devastation, we had a real question. Would the internet be able to withstand a disaster of this magnitude? And so we turned to our traffic graphs again. Now, you can see a slight dip in traffic occur in the immediate time of the earthquake. But this rebounds back to pre-earthquake levels almost that day itself. And it wasn't just graphs. There were stories from the ground that told us this. This is an open letter of thanks we received from Ruth Shiraishi, a Google user in Tokyo, Japan. And Ruth told us that on March 11th, our technology helped change her life. So in her words, at 2:46 p.m., when the earthquake struck Japan, our phones would not connect. Our desktop email systems would not go through. Our phone's SMS would not work, but Gmail connected. Gmail connected us with each other in the company, to our loved ones around Tokyo, and worried family and friends around the world. And it wasn't just Gmail. It was other internet sites. It was Twitter. It was Facebook. It was the power of the internet to connect people in the aftermath. Now, we knew people were going online to find information. And we knew there was also a tsunami alert that had been issued for most of the Pacific Rim countries. And so Google decided to use Google.com, which gets billions of eyeballs every day, as an alerting platform. So we launched this line of text that was a tsunami alert in 4 different languages: Spanish, English, Japanese, and Russian, to warn users that a tsunami was approaching their areas. Now, I said that we knew people come online to find this information. I wanted to prove that with data. So these are search queries for the specific term tsunami coming from the island of Hawaii over the last year and a half. And you see two very distinct peaks in this graph. The first one occurs on February 27th, after the Chile earthquake and subsequent tsunami warning. And the second one occurs on March 11th, after the Japan earthquake. And let's zoom in on March 11th. So again, these are specific queries related to tsunami coming from the island of Hawaii. At around 7:56 p.m., the Pacific Tsunami Warning Center issues a tsunami warning, and you start seeing a slight uptick in queries, which turns into an extremely large peak. Now, this dies down as people fall asleep, but you see a secondary peak occur around 3 a.m. And the reason this is important is because at 3:11 a.m., the first tsunami wave hits the westernmost island of Kauai. So people are coming online to find information and see how this affects them. Now, this peak dies down again at 4:08 a.m., after the tsunami wave leaves Hawaii and starts heading towards the west coast of the US. Now, this peak represents over 20% of queries from the island of Hawaii, which is an extremely large number. And it's not just graphs that tell this story. This is a Reddit post that said, don't know if this is new, but this is a Google feature I can really get behind. And there's a comment on the bottom from a user whose mother lives in Hawaii. And they note that because they opened their browser in the morning, they were aware that there was a tsunami alert issued. Now, Steve pointed out one of the key needs from people after a disaster is getting in touch with friends and relatives. And so we once again launched Google Person Finder. Now, over the course of the last year and a half, the tool has been pre-translated in 40+ languages. So we were able to launch it in Japanese within hours after the earthquake. Over the course of the first few weeks, Person Finder ended up aggregating over 600,000 missing persons records. It partnered with major organizations like NHK, the national broadcaster in Japan, as well as government bodies like the Japanese National Police. In the first 7 days alone, we were able to push 22 different releases to Person Finder. And this included features such as the ability to search in local Japanese character sets, the ability to be compatible with the local tier 2 phones in Japan, as well as features like being able to subscribe to a specific record. Now, this is because App Engine gives you this great ability to rapidly prototype, and web applications also allow you to quickly make these changes on live tools. This is actually our App Engine dashboard a few hours after the tool was launched, and what you're seeing is a peak in users coming to the site. This actually peaks at a little below 1,500 queries per second. In terms of analytics, that's about 36 million page views in the first 2 days alone. Now, what's important here is App Engine can elastically grow to support this peak. Our engineers didn't build a tool that could scale like this. And the fact is, crises have tools that require that need this sort of elastic capability. The fact is, the tools often lie dormant for a large amount of time until the crisis occurs. We again launched a landing page to aggregate information like Person Finder, donations, relevant maps, as well as real-time user-generated content. But we also had alerting information on this page, such as rolling power outages that were occurring throughout Japan, as well as transit outages. Now, I wanted to point out that one of the sites we linked to from this site, again, it's not just Google, was sinsai.info. And this was the local Ushahidi platform. Again, Ushahidi was that incident reporting platform. What's interesting, though, is Ushahidi was launched by a group of local volunteer developers. Because the tool was simple to use and open source, local developers could pick it up, translate it, and launch it for the Japanese public. Now, we also wanted to make other mapping information available. And so what we did was we decided we wanted to put shelter information on a common map as one example. Now, shelter information was strewn across numerous government websites, state government websites, in formats such as PDF. And so we scraped this information, pushed it to a fusion table, and then made it available in one location. Now, it's really important to see information like shelter information on a map so you know which shelter is geographically closest to you. There was something else interesting that was occurring, though, at these shelters. People were maintaining written lists of people who had come to the shelters and posting it on common walls at these shelters. Now, this was essentially their version of Person Finder that was, again, siloed per shelter. And we wanted to be able to sync this up to the online Person Finder tool. So a group of engineers and product managers in our office in Japan decided to get volunteers to go to the shelters, take pictures of these lists, and upload them to a simple-to-use common Picasa album. And then we had volunteers come and transcribe these specific photographs and the names on them and post them to the comments, which we then pushed back into Person Finder. Over the course of a few weeks, we ended up processing over 9,000 photographs and updating 137,000 names in Person Finder. This was possible because we had thousands of volunteers from outside of Google who were able to help us out. And we were able to manage that queue by building a simple tool that handed out tasks to them over App Engine. Again, I said this was possible because we had this great team of product managers and engineers in Tokyo who worked tirelessly for 3 weeks. This is them taking a pizza break a few days after the earthquake. And it was really inspirational work. They had over 40 launches that they did. But at the end of the day, any of you as developers could have taken part because most of the work that they did was simple, used standards, and open source tools. But we'll get back to that point in a second. I wanted to point out what is it that Google is looking to do next. So this is an image from Google Maps of me searching for Tsunami, Hawaii in the aftermath of the earthquake. And you can see the first result is the Pacific Tsunami Museum Incorporated. Not very useful. So we want to be able to get this alerting information across all the properties on the web that people go to find information. This is that same Reddit post, and this is a comment at the bottom of someone saying that they didn't see the alert on their mobile phone. Why didn't their mobile phone wake them up if they were asleep on the beach? Our landing page required contributions from dozens of Googlers around the globe to get all this alerting information online and in a common format. How can we get this information in advance of the disaster so that we need not have to do all the work after the disaster to get it up there? And so this is where I wanted to pose a challenge to the audience out there. At the end of the day, you're all the developers with a great understanding of web tools, whether that be mobile, the Maps API, Fusion Tables, or even App Engine. And you really do have an ability here to take part and make a difference. And I wanted to give a small story of 2 web developers in Pakistan. So these 2 guys were a little annoyed that India had better base maps than Pakistan did on Google Maps, and they decided they were going to do something about it. So they got a bunch of friends together, and they said, we're going to start mapping out Pakistan, and we'll start with Lahore. Now, the time-lapse photography behind me gives you an idea of how the map grows out starting in June 2008. It gets filled as volunteers add data. This is completely crowdsourced data collection. Now, these 2 developers ended up being the top Google MapMaker mappers in the world. But why this is important is last August, Pakistan was inundated with floods that covered over 20% of the country. And Google MapMaker had better base maps than the Pakistani military did. We were able to share this data with UNICEF, the UN's mapping organization, which was then able to help aid organizations deliver aid from point A to point B. These are 2 web developers with an idea to get friends together that ended up saving tons of lives. And it's not just Google in this space. You can actually join the Crisis Mappers Network, which is a group of volunteers that get together and map out areas in need of assistance. We talked about how useful OpenStreetMap was after Haiti. There are also specific tech organizations. We talked about Ushahidi, Instead, and Frontline SMS. All 3 of these organizations have open source code bases and very large issue trackers that could use developers like you to help them out. And to get your feet wet, you can always join a local crisis camp that's held by crisis commons all around cities around the world. Now, these crisis camps bring together aid organizations as well as developers like yourself to discuss problems and possible solutions. Google, Microsoft, the World Bank, Yahoo, and NASA all run the Random Hacks of Kindness together. And so ROC is a conference that's a 72-hour global hackathon that are run in cities across the globe that look to bring subject matter experts as well as aid organizations in the same location to pitch problems to have developers rapidly prototype and create solutions. Now, don't worry, in 72 hours, there'll be a lot of pizza and Red Bull also there. And we actually have ROC number 3 running on June 4th and 5th. This is ROC number 3. It's actually the 4th ROC, but as every good geek knows, you start counting from 0. So that's why it's ROC number 3. I wanted to give an example, though, of where a ROC hack was super useful. So there's this hack called Chasm that came out of ROC, and it's to identify areas that are prone to landslides. There was this huge equation that a World Bank engineer had, and you either needed to have a PhD in math or a PhD in geology to actually understand how to use it. Now, what a bunch of developers did was they took that equation and they created a simple web application around it. So aid workers could actually put this information in and know where to dig trenches to avoid future landslides. It's a great example of something you can do in 72 hours. Finally, there are a lot of non-tech organizations out there, though, that could use your help, and all crises are local. I would encourage you to go talk to your local Red Cross, your local fire department, or your local sheriff's department and see where they could utilize your help. Understand their processes. Help them switch from using pen and pencil to using internet technologies to solve some of their problems. Maybe you could help get local shelter information into fusion tables, local evacuation route data into KML before the disaster actually strikes. Maybe you can help your local sheriff department send out alerts using a format like the Common Alerting Protocol. I wanted to conclude by giving you one final example of helping out in a local disaster. First Responder is a tool that helps fire chiefs understand the location of their staff before, during, and after a fire response. Now, it was built by John Riley, who's a volunteer firefighter. And John definitely doesn't consider himself a web developer, but he's dangerous enough to code. So what John did was he built a tool that uses Google Voice to accept incoming calls, and then uses Google Latitude to track the location of all the firefighters. It uses the Google Maps API to give them turn-by-turn directions. It uses App Engine to log when everyone shows up. And it also actually makes sure that everyone is accounted for after the fire response. It's this great example of using simple, standard, and open to solve a very important local problem. First Responder is actually an open source tool that you can find on code.google.com. So I wanted to conclude by conveying to you my real excitement in this space and the possibilities that technology has here. I really believe we're at this turning point where technology, widely accepted consumer technologies, can really help in alleviate suffering after a natural disaster. I think that all of us, whether we're geeks or developers or citizens just interested in doing good, really have a chance to make a difference here. I wanted to thank you all for your time. Steve and I will be here for the next 10 minutes. If you have any questions, there are 2 mics set up on the right and left. We'd be happy to answer them. Thanks again. No questions?
Hello.
Hi.
I was wondering if you could just talk a little bit about how you sort of alluded to things like Ushahidi and other organizations. Talk a little bit about verification. You know, you have this great crowdsourced data. You mentioned the OpenStreetMaps in Haiti, all of this stuff. You know, I'm from a media organization, and the issue of how do you know how reliable this information is, you know, at different stages. You have the source in the output, but translating that, just how do you guys approach that?
So this is a great question. So the question is basically, how do you make sure that your sources are correct and verifiable? And the fact is, this is an open area right now. So Ushahidi, for example, tries to get more than one record so that they can verify that something is happening there. OpenStreetMap and MapMaker use a version of moderation, so other people with local knowledge can say, yeah, this is probably right. Now what's interesting is, though, the power of the crowd is really able to reduce the amount of spam or false reports that you see in a lot of these cases. Another good thing is humans tend to be good in these situations, and you don't see many of these cases, but they do exist. And I think this is also a case where local aid organizations do play an important role of providing that verification to make sure what's being provided is truthful.
Just as a short follow-up, so I'm wondering if you automate the threshold for then publicizing information. In other words, you said Ushahidi does multiple things. Like at what stage do you say, okay, and is that programmatic? You know, how do you define, you know, sort of in advance of it, how do you define, okay, what's our threshold for saying we think this is a valid entry or we think this is not a valid entry?
So you can use a lot of signals from the internet. So there's actually this great story of this group from MIT that won the red balloons competition that was posted by DARPA. And this was to find red balloons that showed up randomly around the country. And they used things like the location of where the information was coming in to see whether, you know, the guy who says he knows where the balloon is in California was actually sending it from Oklahoma and was probably lying to them or not. And so you can use signals like this, and I think each organization uses different levels of signals and a different threshold on where they consider it okay to publish this. Now, I should point out that in the case of publishing things like alerting data that we're interested in doing, we want to make sure that comes from an authorized source, a government agency or someone who actually has knowledge of the situation and that we're just the dissemination channel for that information. Thanks.
It seems like your tools are after the fact. What are you doing before the fact in terms of having people pre-register, or a Facebook app where you can, register yourself with the Google database, so when a disaster does hit your area, your friends know how to reach you and know that they have, the right record?
So there is a lot of work done by different groups on things like making sure you have an in case of emergency contact in your phones, knowing what to do, or pre-education in the aftermath of, before a crisis actually happens, like what to do when an earthquake happens, things like that. One of the things that we're doing specifically as Google is we're trying to get alerting information out there. So a key example of this would be the tornadoes that hit at night in the southern part of the US recently. We want to be able to give alerts to people who are in that region who might be asleep. Maybe we can eventually wake them up to let them know that they should head to their basement. So these are things that we want to try to do to pass this information out in easier format so people can read them regardless of what they're using.
Do we know the name of those Pakistani developers?
I do, but I'm forgetting them. We can follow up later though, and I can try to get them to you.
So you mostly talked about natural disasters until now.
Mm-hmm.
Can you relate to humanitarian issues or things like political issues that we've seen, and what's Google's position on what you guys are doing, things like this?
So that's a great question. So the fact is that our team is focusing right now on natural disasters. There've been a lot of them lately, and it's keeping us pretty busy. The fact is we have left the door open, though, to work with humanitarian crises also. We have done some work in the past, for example, with MapMaker to map out the southern Sudanese region. There was a program with George Clooney called Paparazzi in the Sky, which the idea was have a satellite over the area to prevent future violence. So we're looking at areas like that. We think right now most of our tools, though, do focus on natural disasters.
I was wondering if you guys have reached out to the wildland firefighting organizations. In my experience, they constantly deal with these kind of disasters and have some pretty good tools to support them.
So actually, this is a very important area too, and so I assume you're talking about the wide forest fires and the groups that fight those. So we do have some tools that they use using Google Earth, for example, to be able to model out wind patterns and how the fires are moving, and so that they can use this without needing an internet connection as they're literally jumping out of helicopters and things like that to fight these fires. And so we have some specified tools for these different groups. The tools that we're building, though, as a team tend to more focus on general consumers who are interested in finding information and making sure that information is available to them.
Yeah, just kind of going back to you had talked about the responders as a group that didn't have great uptake during Haiti. And I know as responders, they have a bunch of tools and would probably give really good requirements. So something to maybe look at.
Definitely,
Great.
we definitely will.
Thanks.
Have you been playing with the time scale of the model that you're working on? Like in a crisis, everything's up in the air and everybody needs to fix it in a hurry. And when the crisis is over, you get to throw away all the data, or you don't have to worry about curating it quite as much. But if you spread out the timeline, then curation becomes a bit more important, and the needs become a bit more diverse. So like chaos mapping instead of just crisis mapping. And also, have you gotten a lot of call to participate in war zones?
So going back to the war zones issues, so we have been asked to help out numerous times. Right now we're not experts in those areas and we don't really understand them as well. So as I said, we're focusing on natural disasters currently. With your previous question about wider mapping, I think a lot of the tools that we are building are applicable in cases that are general crises or in broader contexts. We might be focusing just on this, but we try to keep kind of the vision a little broader. So mapping is mapping at the end of the day.
So I just was sitting here and thinking it was really interesting that there were so many people in the session, and wondered, and maybe I'm making some assumptions, that we all kind of care about people and we care about helping people in crisis. Is there a kind of a general group where, because I was thinking it'd be awesome to be able to exchange business cards with all of you, or make some sort of contact or connection where we can collaborate together generally, not about a specific thing like, the people finder or the alerts, but in general.
So let me repeat that on the mic for everyone. Crisis Commons is the group to join. So Crisis Commons at googlegroups.com. It's a great group. I mentioned them earlier. They're the ones who host the crisis camps in cities. But it's a great mailing list to join to see, for example, little state organizations might email that group and say, I have all this data on an Excel spreadsheet. Can you help me put it on a map?
Crisis Mappers is also another group that we mentioned. If you have specific information, mapping expertise or GIS expertise, they're also another great group to join.
Hey, these are some really awesome tools you guys have put together. I'm a developer for a news organization. When an event like an earthquake takes place, is there a particular place we can link to so I can tell the editorial team where to go, just directly to Person Finder? Or do you guys actually have to go create an event to say this earthquake has happened, for example, before we can link to it?
So let me talk about the specific event. So usually, if the event is big enough, if you go to google.com, you should find the information there. And so you should be able to search for it on our properties, or you'll see a little link on google.com if it's a large event. The other place you can go is google.org/crisisresponse is our site, and we have recent responses that are listed there, so you can kind of get an idea of some of the stuff we do.
We'll also be tweeting. Anytime we do a big response, we'll definitely get it out there in the Twitter sphere, like what we're doing.
And this is really interesting because the last time when we launched Person Finder, we tweeted about it. So we tweeted about it a few minutes after it launched, and we just saw the QPS spike. You know, and I mean, I guess I should know the power of Twitter because I work at Google, but I was again shocked to see just how many people picked up on it before we even had a landing page aggregated and ready to push. People were using the tool.
So with maps, there's a lot of IP involved with it. How do you guys deal with that during the crisis? So for example, the Pakistani people that made the Great Base Map that wasn't pushed out to the community afterwards, it kind of lives in Google now.
Mm-hmm.
And for example, probably at the OSM, you guys could get that data because it was encumbered. So, I mean, I deal with it every day. How do you guys deal with it in the nonprofit organization? I mean, very carefully is probably the solution.
Well, yeah, very carefully is a good answer. But I want to give you a more honest answer to that, which is that we're always looking to get better. And so this is definitely a place where I think we can get better. Now, in addition to that, I wanted to add, though, that this data is available over the Maps API, for example, and that when there is a disaster in a region, we do provide this data to organizations like UNICEF so they can make it available to all aid organizations. And so we'll continue to work on this, and we'll continue to see if we can help in this area.
Just to follow up, you guys probably know this as well, but you guys have been pushing the aggregation of data as one of your goals. And it's just, when it comes to mapping data, it's kind of frustrating because you can't aggregate that data because someone OSM might have a road that someone got lazy and didn't put it into MapMaker and vice versa. And I mean, there's no answer, correct?
So we're very aware of this. This is somewhere where we want to be able to help out better.
Maybe the engineer can answer this, but like, is that something that your table data might be able to use as
Tablecast, that's actually probably a really good example where you can try to get these different organizations to be sharing these updates between these groups. Yeah, that's definitely.
Middle-aged men like myself will have a heart attack, get very interested in their health because the crisis is acute. You go to the hospital, you go on the cholesterol-reducing drugs. But what about the chronic crises, like ocean acidification, low oxygen zones, overfishing, things that have the potential to kill billions of people? There are certain scientific organizations, I'm one of them, we sit on petabytes of data that could be used in front of crises in a more offensive position rather than defensive, waiting for something to happen. Is your team at all interested in those types of problems?
So there's actually a great google.org project called Earth Engine. And what Earth Engine is trying to do is take these petabytes of data regarding the globes and push them together and give Google's computing power to be able to conduct algorithms over it. And one of the examples is one of these chronic crises, which is deforestation. So using this globe of satellite imagery from the last 30 or 40 years, you can actually see deforestation occur in different areas. So there are different google.org teams that focus in these different areas. I wanted to thank everyone for their time today. We're unfortunately out of time. Steve and I will be around kind of off stage for a bit. If you have any follow-up questions, you can feel free to find us. Thanks again for coming out today.
Thanks a lot.